Problems on waveform synthesis. So far we have seen how to achieve the waveform and their Laplace transform, but now we will use it in the circuits. Let us see problem 1. In the problem 1, we have an inductor, a 2 millihenry inductor with some initial current can be represented as shown in figure, where S is Laplace transform variable. The value of initial condition we have to calculate. It is given in GATE 2006, 1 mark EC. Options are 0.5, 1 ampere, 2 ampere, 0 ampere. So look at the circuit. The circuit is like this. We have an inductor and we have one value there that is given. This value is given as 0.002 into S. S is Laplace transform variable. Okay. This is 1 millivolt. This is I of S. Okay. Then we have to calculate initial value of the current. See, if you want to say, for example, this is V of S. Now please get the KVL here. I will say plus minus here. V of S minus I of S into 0.02 S minus 1 millivolt is equal to 0. That is what we get. Suppose in time domain VL of t is equal to L di by dt, and when you take Laplace transform, you can say L into S into I of S minus I of 0 plus. This you can say L into S I of S minus L into I of 0 plus. So this is initial value. Okay. Initial value due to inductor. Now if you really see this, VL of 0 is L into I of 0 plus is equal to 1 milliampere, 1 millivolt. Then what is L? L is given as 1 millihenries. Therefore, I of 0 plus is equal to VL of 0 plus by 1 into 10 power minus 3. This is 1 into 10 power minus 3, 1 into 10 power minus 3. So look at the inductor is given as 2. So 2 milli cancel. Therefore, I of 0 plus is 1 by 2. 1 by 2 means 0.5 amperes. So our option is A. Let's go to second problem. If Laplace transform of voltage across a capacitor of value 0.5 farads is S plus 1 by S cube plus S square plus S plus 1, the value of the current through the capacitor at t is equal to 0 plus. GATE 89, 2 marks. Let's calculate Laplace transform of voltage is given across the capacitor. We want to know the current. Okay. So look at this. Here is a capacitor. Say this is current. This is voltage, 0.5 farads. And he gave I of S into Z of S is equal to V of S. What is I of S? V of S by Z of S. What is Z of S of a capacitor? For a capacitor, 1 by Cs. Then this is nothing but V of S by 1 into C of S by 1. What is V of s? He is asking I of 0, limit s tends to infinity, s into I of s. That limit s tends to infinity, s into V of s by 1. V of s will write it. What is given V of s in the problem? S plus 1 by s cube plus s square plus s plus 1 into, this is s here, V of s is here, C of s 0.5 into s. Look at this fact. Okay. Now, limit 1 by s tends to 0, 1 by s, okay, s into another s here, s here, 1 plus 1 by s, divided by s cube, 1 plus 1 by s, 1 by s square, 1 by s cube. Now what will happen? Into 0.5. So this s could cancel, 1 plus 0 by 1 plus 0 plus 0 plus 0 into 0.5. So answer is 0.5. That's the answer. V2 for the input voltage of 10 ut. So look at the circuit. Circuit is given like this. First 10 into ut step. Then you have Vx here. Okay. Then you have capacitor. Then you have R3. Then he gave dependent source. This is called C2, for example, or some C, say some R, okay, call it as R1. This is 2Vx. Whenever we say Vx, we should ask where it is depending on. So this is depending on Vx here. Then you have parallel. In the parallel combination, he gave R, L. Then finally he gave resistor R4, R3, L. This is the circuit given. Then call this as V2. Indirectly, there is no switch involved, but still it is called transients, because when you give step means starting from 0. It is as good as a switch is connected here. So though there is no switch, we are still calling as switch. That's the first thing. Second aspect is, for objective questions, he cannot ask V2 of t. So better we say V2 of s we will calculate and leave there, because if you take inverse Laplace, you will get V2 of t. That's what I am going to do now. So this is our third problem. Understand? Now let's go one by one. Another serious observation I am telling you, L becomes 1 by L, L becomes Ls, C becomes 1 by Cs. Okay. L becomes Ls, C becomes 1 by Cs. Anyway, R remains as R. How does this come? This is all valid only when initial conditions are 0. if initial conditions are 0, you can always call L as Ls, C as 1 by Cs, R as R. Now look at, I am going to call this as, for example, Z. That's another one. So what I am suggesting is just take KCL. Call this as V2 of S, call this as 1 by Cs, call this as Ls. Now I will tell you. So take KCL at V2. I will give you an equation and then solve. V2 of S minus, this becomes 10 by S. 10 by S divided by R1 plus 1 by Cs, okay, plus V2 of S minus 2 into V of X divided by R3 plus V2 of S by R4 plus parallel combination of R3 into Ls is equal to 0. This is the equation by which you can solve for V2 of S. But only one thing I should help you is, what is Vx? Vx is how much? Vx is the current through this multiplied by R1. What's the current there? If this is positive, current we assume here. So 10 by S minus V2 of S divided by R1 plus 1 by Cs is the current. That multiplied by R1. So please take this value of Vx, substitute over here, solve for V of S, then take inverse, you will get V2 of t. So this is the problem expected. That's why most of the times, in objective exam, they are straight away asking V2 of S. Because taking inverse Laplace, it will take long time. That is only for conventional exam, right? That is the approach. Calculate differential equation for I of t for the circuit shown. Please observe this problem. He is not asking the solution. He is not even asking I of S. He is simply giving differential equation he wants. What is the circuit given to us? This is the circuit. He has used all the three elements. Okay. All the three elements he has used. For example, sin t is here. Okay. R, L, C, this is I. Understand? For this, values are also given. His very funny way, he said 2 ohms, 2 henries, 2 farads. Just the differential equation. Take KVL. Sin t is equal to Ri plus LdI by dt plus 1 over C integral I dt. Generally we say minus infinity to t. If they don't say anything, we assume initial conditions at 0, we can simply cancel and say 0 to t. He wanted only differential, but this is called integral differential because integrals are also available. When integral differential equation is there, then please go for differentiation. It becomes cos t r di by dt plus L d square I by dt square plus 1 over C into I. This is called differential equation. So that's a very simple equation. He is asking only differential. He is neither asking it to, he is not even asking I of S. He is not even asking I of t. Why? Because for just 1 mark, he cannot ask the Laplace transform, not even ask for the inverse Laplace. If he is asking for the Laplace transform and inverse transform, he has to give 5 marks. That's why Simply he is asking equation here. Let's go to fifth problem. Calculate I of s for the input voltage given 10 into e power minus t ut. Once again, ut means switch. Then if you look at the circuit is given as just L. There is a resistor and inductor I. This is 10 into ut, 10 into e power minus t into u of t. Our resistance is given as 2 ohms. Inductance is given as 1 Henries. That's the circuit. So we have to calculate I of s. Look at here. Again, he is not asking I of t. So when you say that, when you look at the problem, fifth problem here, I am giving you how to get I of s is the question. So go for KVL. If you go for KVL, 10 into e power minus t ut Ri plus L di by dt, that's the meaning. Take Laplace here. 10 is 10 by s, ut is 10 by s, e power is 1 by s plus 1, r into I of s, L into s into I of s minus I of 0. Cancel. I of s is 2 plus 1 into s, yes, here is 2 into s, into I of s is equal to 10 by s into s plus 1. So what is I of s now? 10 by s into s plus 1 into s plus 2. This is the answer. So he is asking us to calculate 10 by s into s plus 1, s plus 2. Let's go to sixth question. Calculate I of t for the input voltage of 10 into delta t. Delta t means impulse. So, question number 6. What's the circuit first? That is also same as previous. You have an inductor, resistor here. Inductor is 1 Henry, 2 ohms. Input is 10 into delta t. I is here. So we can take I of t level, or you can start it. So what to say is, apply KVL. 10 into delta t L di by dt plus Ri. Please observe, this circuit can be put in this form, like this. That's how we can have it. And by that, the interesting thing is, inductor current is 0 plus 0 minus is 0. That means I of 0 plus I of 0 minus also 0. That's why most of the time we are ignoring them. Look at here. 10 into 1 Laplace transform. S into I of s minus I of 0 plus r into I of s, cancel. Therefore, 10 is equal to 1 into s plus 2 I of s. I of s is 10 by s plus 2. But please observe, he is not asking I of s. The question says calculate I of t. Did you observe the difference between this problem and previous problem? This problem is, the answer is so simple. That's why he is asking inverse also. Let us take inverse Laplace. I of t will come 10 into e power minus 2t into u of t. This is the answer. So always observe in objective question exam, if the question is big, they will ask just intermediate steps. Question is small, they will ask complete steps. And here initial values I have taken very quickly, because in the previous lectures I have given a big lecture, complete lecture on initial conditions. Now initial conditions are always 0, particularly when there is inductor. Let us go to 7th question. A voltage form V of t is given as 12t square. This is a parabola applied across 1 Henry inductor for t greater than 0 with initial current through it being 0. The current for t greater than 0. Options are given 12t, 24t, 12t cube, 4t cube. Let us see what is going to happen. What exactly it means? Let me just help you. He said there is an inductor. That's all. For that he has given the voltage. Question number 7. The voltage is given to us 12t square. Okay. Value of the inductance is 1 Henry. As I told you, for all initial conditions we will take it as 0. That's why I can simply say L becomes Ls. He wants current. Say if I say this is V of t and this is I of t, understand? So V of t is equal to L di by dt. That's all. This is simply Ohm's law. Now if I take Laplace transform, V of s is equal to L into f of s minus I of 0 plus. This I neglect. So finally what is happening? What is V of s? 12 into t square. What is the value? Factorial 2 means 2 by s cube. Laplace transform, if we take L is how much? 1 Henry. S into I of s. Therefore, I of s is equal to 24 by s cube, another s comes here, s power 4. Okay. Now what you do is, you can say this as, adjust this as factorial 3 into something divided by 3 plus 1. That's the meaning. What is factorial 3? Factorial 3 is 2 into 3, that is 6, into something by s cube plus 1. For 24, how much should I write here? If I write 6 here, how much I should write? 4. So therefore, if you take inverse Laplace, that is, this all goes into inverse. So I of t is equal to 4 into t cube. That's the answer. Option is D. Problem 8. In the figure shown, assume that all the capacitors are initially uncharged. Vi is 10 into ut. Calculate V naught of t. K 2006. 1 mark EC. See the options there. We will take the circuit. The circuit is basically parallel combination of this thing. Like that. 1 kilo ohm here, 4 microfarads, and 4 kilo ohms here, 1 microfarad. Very funny, reversed. That means Vi of t over here, V naught of t over here. Understand? Very simple problem. But as I have been telling, again input is 10 into ut. Why I am bringing all these problems under this topic? Because this is also under waveform synthesis, in the sense to say it is ut. And what is the transform here? 10 by s. Where is the switch actually? Switch is not there, but it is acting as switch, because step means starting from 0. So whenever there is a ut, you have to take it as a switch. Another important thing, he said in the problem, all capacitors are initially uncharged. That means there is no voltage. For example, you call it as R1 or C2, R2 C2. For example, Vc1 of 0 plus is equal to Vc1 of 0 minus, Vc2 of 0 plus is equal to Vc2 of 0 minus. This is 0, this is 0. Who said that? He gave it. We are not doing it. Even if I am supposed to do, I will still do the same, because switch is given at t is equal to 0. Before switch is given, no voltage given. No voltage given means, can the capacitor develop any voltage? No. Therefore, whether he says or I say, both are the same. He's already said it and saved your time and my time. Therefore, let's go ahead. Let's see this value, and you call this as V naught of s over here, and this C you say 1 by C2 of s, C1 of s here, and this is 1 by C2 of s. Therefore, I am going to say simply Z1 of s is equal to R1 parallel 1 by C1s. Z2 of s is equal to R2 parallel 1 by C2 of s. Then what is V naught of s here? How does it go? Simply a potential divider for me. If I have to say, if I call this as Z1 and Z2, then V naught of s is equal to Vi of s by Z1 of s, Z2 of s multiplied by Z2 of s. Why? This by this gives you current into this, or you can say potential divider connection. And calculate where V1 of s is how much is given? 10 by s. So calculate V2 of s, V naught of s, then take inverse Laplace transform. You will get the answer. The answer is C, 8 into u of t. Let's go to 9th problem, question number 9. For RL circuit shown in figure, the input voltage given is ut, the current I of t, what is it? Given in the gate 2004. So let's calculate what is ut. First, what is given here? This is I of t, 2 ohms, 1 inductor. Please observe, the same circuit is repeating, and this is Vi of t. What is Vi of t? Vi of t given in the question is u of t. That's given in the question. Then, as we are already saying, IL of 0 plus is equal to IL of 0 minus is equal to 0. Why? Because you are giving step. So, Vi of t is equal to Ri plus L di by dt. If you take it Laplace transform, R into I of s, L into s of s plus minus I of 0 plus. This is 0. How much is that? He said ut. That means 1 by s, 2 plus L is 1 into I of s. Therefore, I of s is equal to 1 by s into s plus 2. That is only I of s, but he wants I of t. If you want psi of t, the best thing you can go is this s plus 2. In the process, what is k1? S into I of s, s equal to 0. K2, s plus 2 into I of s, s equal to minus 2. So if you cancel this, this is s plus 2, this is 1 by s. S equal to 0, 1 by 2, s is equal to minus 2. If s is equal to minus 2, minus 1 by 2. If you multiply this, s cancel, s plus 2 will come as 0. S plus 2 means s plus 2 cancel, 1 by s, 0. Therefore, you are getting these values. So, can I help you now? So, when you say I of s here, okay, half by s minus half by s plus 2. Then the whole option is going to be I of t, if I want to take inverse transform, 1 by 2, okay, 1 minus e power 2t into ut. Good. Look at the options. Now you can understand which one I have to take. Answers are very simple according to my equation. To check the answer, put t is equal to infinity. I of infinity is half into 1 minus e power minus infinity, cancel, 0.5. So look at the options there. Let us see now. According to ABCD, B is correct, C seems to be correct. Now rule out A and D, because the maximum value that I am going to is 0.5. So we have options only between 0.5 and 0.5, that means B and C. When the B and C are representing, the next struggle that you need to know is at what value that 0.31 is coming. At what value the 0.13 is coming. Suppose if you give 2 what comes here, give half what comes here, finalize. Suppose if you give half, then I is equal to half into 1 minus e power 2 into 1 by 2. That cancel. E power minus 1. That is really becoming as 0.31. So, first by getting 0.5, we understood that the answer must be B or C. By substituting half, we got this answer. So, the final answer is C. That's the best way and to handle this issue. That's the end of this problem.